everyone. Today we're going to be going over Chapter 4 from your textbook on program flow control. So basically this is just different methods that we can use to influence the output of a program depending on conditions that we specify. So as usual, here's our chapter outline. We're going to be introducing branching statements and loop statements. And then we're also going to show some methods that you can use for early termination of either a for or while loop. So our objectives are to introduce the various means of controlling the order in which a program's expressions can be evaluated. And we're going to introduce a set of relational and logical operators that are used to accomplish this control. So to start, the basics of program control, you have four statements that you can use. It's the while, if, for, and switch statements. And each time one of these statements appears, it must be followed later by an end statement. And all the expressions that appear between the control structure statements and the end statement are executed until all requirements of the structure are satisfied. So each of these control structure statements can appear as often as necessary within themselves or within other control structures, which we'll show you shortly. When this occurs, those are referred to as nested structures. So these are the different relational and logical operators that we have. Relational operators are the typical ones that we're used to seeing: equals, not equals, greater than, less than, greater than or equal to, less than or equal to. However, the notation that you need to type into MATLAB may be a little bit different. So up to this point, you've seen we've used the equal symbol, like when we've done variable assignments or when we're creating an expression in MATLAB. Now, when we're doing control structures, when we use the equal symbol within those control structures, we have to use two equal signs. And then when it's not equal, you can see here that we use the tilde symbol. The tilde is what means not, so not equal. And then the less than, greater than, again, these are the notation that we're used to, so that should be nothing really new there. Logical operators, we have the and, or, and not. So what logical operators do is they create a way for us to kind of combine conditions to where either both have to happen or one or the other has to happen in order for a statement to be true. So for example, with and, we can use one and symbol or two and symbols, but basically what that means is if we have condition A and condition B, both of those have to be true in order for the script below it to be executed. If it's an or statement, that means either one of the conditions, either condition A or condition B, has to be true to execute the following script. And then not is basically just used to negate a condition. So when we use control structures, we need to indent the statements following each control structure definition up to but not including the end statement, and we'll show examples of that shortly. This greatly improves the readability of your code and is considered industry practice. When the structures are nested, the entire nested structure itself needs to be indented as well. And when we're using MATLAB's editor, the indenting can be done automatically for you. So let's take a look at an example of using the logical operators here. Suppose that we want to create a function g of x such that g of x is equal to f of x when x is greater than or equal to a or less than b, and equal to 0 when x is less than a and x is less than or equal to b. The logical operator is performed using this expression here. That's how you would write it out in MATLAB, where a and b have been assigned numerical values prior to this statement, and x is, again, greater than or equal to a and x is less than b, is the logical operator that has a value of 1, meaning it's true, when x is greater than or equal to a and x is less than b. Its value is false, 0, for all other values of x. So let's take a look at an example using that. So we have a is equal to -1, b is equal to 2, and then x is this vector array here. And then we can execute this script. So we have r is equal to a that's less than or equal to x, and p equals x less than b. And then here is using the AND statement. So in this case, R and P must both be true in order for the overall expression or statement to be true. So when we execute it, we can see that R is equal to 0, 1, 1, 1. So that means that in this particular case, it was false. In these cases, for the vector, R was true when it was evaluated. Same thing with P, only we see now that the first three elements were true. They satisfied the conditions, but the last element of P did not. And then when we used the AND statement to see if R and P were true, that means that this here was false, true, true, false. And we can see that because, again, they needed to be the same. So 0 and 1, 0, 1 and 1, that's true, 1 and 1, that's true, and then 1 and 0, that's false. So look at the first column of vectors R and P and notice that the values do not match. Since the logi function was an AND statement, then it returns a value of 0 for false. This logical operator can be used to create the unit step function as well. If you're not familiar with it, a unit step function is just a discontinuous function whose value is 0 for negative arguments and 1 for positive arguments. So this is the general expression that we use to create the unit step function. If t varies by increments of 0.25 in the range from -1 to 1, then the following script can be created to create the unit step function. So here we're using our colon notation where we're doing the increments of 0.25 from -1 to 1, and then unit step, we're using our relational operators. This here is going to display for our table. This is just going to display the text headers here, and then we're going to display t and unit step. And notice that the transpose symbol has been used here to make those columns instead of rows. So now you can see when we execute, when values are -1, then the unit step is 0, and when the values are positive or equal to 0, then the unit step is 1. So that satisfies the definition of the unit step function. All right, so now we're going to take a look at those 4 statements that we mentioned earlier that you can use for control structures. So the if statement is a conditional statement that branches to different parts of its structure depending on the satisfaction of certain conditional expressions. This here is the general form of the if statement. So you have if condition 1 happens, then execute these expressions or statements. Else if condition 2 is satisfied, execute these expressions. Else, execute these. So this else statement here is kind of supposed to be a catch-all. So if it doesn't apply to this condition or this condition, then all other conditions would fall into this category, and so then we have the expression 3 that would be evaluated. Notice that the if and end statements here, the end of course does need to be there because we opened the structure with an if statement. Also note that the else if and the else are optional. You don't have to use those. You can just use an if and an end if you'd like. Also, you can have more than one else if expression. So you could do if, else if, else if, else if, else, and then end. However, you can only have, per control structure, you can only have one if and one else. If you're using a nested structure, then those can be another if and else statement, but within a single control structure for the if statement, it can only have one if and one else. So here is an example. This, as you can see here, does have the nested if statements, and then this kind of walks you through what parts of the expression would be executed. So we can see here that if j is equal to 1, notice the double equal sign here, then it's going to execute this script here and move forward. However, if j is not equal to 1, then it's going to skip all of this here and come down to this else statement. So here's a couple of examples. You can enter this into MATLAB if you want. I'll be doing this example in the next video where I use MATLAB to demonstrate the concepts from this chapter. So let's say we have j is equal to 2 and x is equal to 1, and then num is equal to 3. In this case, again, because j was equal to 2, none of this here gets evaluated. It just goes right to the else statement. Because j was not equal to 1, and so then this would be our output here. However, in this example, j is equal to 1, and then we have x equal to 1, num equal to 3 again. So because j is equal to 1, it's going to evaluate this expression, then it passes in num, and then it evaluates that. So as you can see, when it goes through here, depending on the number that was entered for x and num, we can see in this particular case that it produced an output for z when it evaluated x with the sine function here, and then the output was nr equals 1 and nc equals 1, and in that case it's because our num was less than or equal to 4, so that's why this one was executed as opposed to this one. That just goes into, you can read that just kind of goes into the explanation of what I just told you, how those expressions there were evaluated, how we arrived at those outputs. Note that when comparing a vector to a scalar, the condition is satisfied only when each element of the vector is satisfied. All right, next up we have the switch statements. The switch structure is essentially an alternative to using the if-else structures. Switch expressions can contain numerical values, a logical value, or a string. So you can see it looks kind of similar to the if statement, but in this case we have cases. And what it does is we have this switch and then expression, and then you'll identify different cases that could occur, and then it will switch between that. So, if case 1 is true, then it will execute these, and then it exits the switch structure. If case 2 occurs, then it will evaluate case 2 statements, and then it will exit the structure. So unlike the if-else, where it could have possibly gone into further statements, this one is just going to evaluate the one case depending on what the input is to the switch structure. So here's an example here. We have k is equal to 3, switch k. So that just means that it's entering into that switch statement. So then we have case 1. If case 1 occurs, then we'll display case 1, or case 2 or 3. Notice that this is the cell notation here instead of like a vector or a matrix. And then we have case 9. Otherwise display this. So again, the otherwise is kind of a catch-all. If none of these cases happen, then the otherwise expression will be executed. So again, here's a couple of examples. I'll be going over these, actually programming this into MATLAB, but I'll go over it real quick. So we can see a is equal to 3, k is equal to 9. In this case, when it passed it in, we can see that it is case 9. And so it's going to display as our output case 9. As opposed to over here, we have k is equal to 77. So when we do that, none of those apply. Case 1 doesn't apply, case 2 and 3 doesn't apply, case 9 doesn't apply. So it is the otherwise expression that is executed, and in this case, it displays the words otherwise. We also have for loops. For loops are used to repeat a series of statements a specific number of times. This is the general structure of the for loop. So we have for variable equals expression, execute these statements. Notice again, we did have to use the end statement to close the control structure. And one or more of the statements within the for loop can be a function of variable that is shown here. So let's say that we wanted to use a for loop to obtain the shortest execution time in our program. This is the syntax that you can use. So we have n row equals, and then what you would make this equal to is a positive integer of some numerical value. And then we have a equals 0 of n rows by 1 column. So this is called an array pre-allocation, and basically it creates a zeros vector of n rows according to the number that you specified here by one column. So then now we have our for loop. We say for r equals 1 to n rows. So that's for all values that range from 1 to n number of rows, execute these statements. And then you have element r of a is equal to whatever. Again, we'll go into examples in the next video that demonstrate this in a little more detail. So the specific thing that we need to note here is the array assignment statement, which is this zeros n row by 1. This is what ensures the maximum speed for the execution time. All right, we can also use for loops to execute for the shortest execution time with nested for loops. And this here is the structure that you would need to use for that. Note that n row and n column are positive integers that previously have been assigned values. So again, we see this array pre-allocation here, but in this case, it's going to create a zeros matrix of n rows by n columns. And then this, now with our for loop, it's creating a column index. Now note that the column index must be the outer for loop. The row index must be the inner for loop, the nested for loop here. And then we evaluate our statements, and then when we're doing our subscript notation, we have to specify a row and a column, as opposed to before where we just identified the row number. And then also notice, because we had the nested for loop here, we do need two end statements. Also notice what we mentioned earlier, that when you're using nested statements, the whole structure needs to be indented. So this end goes with this for, this end goes with this for loop. So here's an example here. You could use this if you wanted to. Basically, the script does the exact same thing that the sort function does, but this just demonstrates an example of how you can have nested for loops with nested if statements, and how you could use that to arrange numerical values in ascending order. Like I said, this does the same thing that the sort function does, so I don't know why you would use this over the other one, but just to demonstrate, I'll go through this particular example in the next video. We also have while loops. So while loops repeat one or more statements an indefinite number of times, and it will only leave the loop when a specified condition has been satisfied. This is the general form, so it looks very similar to the for loop, but in this situation we only have while condition, meaning while this condition is not satisfied, it's going to execute this. Once it is satisfied, then it will exit the while loop. Here's an example here. Let's say that we wanted to do an example on convergence of a series, and we want to determine and display the number of terms that it takes for the series, this series here, to converge within 0.01% of the exact value, which is pi squared over 6. This is the syntax that we could use to do that. So you see here we have a while loop here. We've defined our exact value, the pi squared over 6, and then what we're saying here is while we're evaluating the expression and it's not equal to this exact value, keep performing these statements here. Keep executing these statements. So series plus 1 over k squared, and then k is then incremented to the next number. So again, it's just going to keep going through this loop until at the end the series is equal to this exact value here. So when you execute this, it's going to tell you that the number of terms from this display here, number of terms is equal to 6,079. To terminate a for or while loop early, we can use the break function. And if the break function is within nested for or while loops, then it returns the next higher level for or while loop. So what does that mean? Let's say that we have this structure here. So we have a for loop, while loop, and then an if statement. If we use break right here, then it's going to break out of this and then move to the next statement after that end statement. So just be aware when you're using that, it moves to the one after that statement. All right, so that pretty much sums it up. Here are some examples as usual that you can go through from your text. We give you the problem number. Go through, try these for yourself, see if you can derive the solutions. If not, if you get stuck, come check, and then continue to try and figure out the syntax for the problem. And then if you are able to get through it, then come back and check your answer and see if you got it right. And then, of course, in the next video, I will go through some of these using the conditional statements in MATLAB to really show you guys how to use these and how they can be beneficial when you are solving problems that may require some sort of conditional statement. So if you have any questions, as usual, let me know. Otherwise, I will see you guys in the next video. Thanks. Bye.